Okay, so I hope you're enjoying the video so far. So we are going to be putting what we've learned so far into practice. Okay, so moving on, we are going to be solving a suite of questions. Okay, on the uses of dimensional analysis that we've learned so far. Okay, so let's begin. So this is a question on the use of dimensional analysis. So we are going to see how we can use dimensional analysis to solve a question like this. So let's get on with the question. The question says that the frequency of a vibrating string depends on the length L of the string, the tension T in the string, and the mass per unit length mu of the string. Using the proportionality constant as 1/2, establish an equation between F, L, T, and mu. So someone performed an experiment and realizes that involving a vibrating string, okay, they realizes that these are the physical quantities that relate, okay, but the person doesn't know how they relate, okay, but probably the person went ahead and performed more experiment and realized that the constant proportionality is half. But then the person realizes that one can use dimensional analysis to what? Find the relation between these quantities, or the mathematical expression between these quantities. And so that's basically what we are going to be doing. How are we going to use dimensional analysis to find how the frequency depends on the length, and then the tension, and the mass per unit length. So the first thing we are going to do to solve this question is, of course, to pick out our physical quantities. Okay, so we are going to define our physical quantities. There is frequency, F, there is length, L, there is mass per unit length, mu. There is, what else? Frequency, length, mu, and an extension, T. Okay, mind you, this is dimensional analysis, so before we move on, must make sure that you find the dimension of these physical quantities, because that is what we are going to use to solve the question. So the next is to find the dimensions of the physical quantities we were given. So frequency, dimensions of frequency. Frequency is 1 over period, or the inverse of period. Okay, so that will mean that period is time. So that will mean the dimension of F will be T minus 1. The dimension of tension is force. And so the dimension of tension will be M L T minus 2. Length, that is obvious, is L. And then mass per unit length. Mass per unit length means mass over length. So that will be M L minus 1. Okay. Alright, so now doing this is not enough. After finding the dimensions of the physical quantity, it doesn't tell us the relation between them. So how do we do it? We are going to write a mathematical expression to represent what the question says. The question says that mathematically, it says that the frequency depends on, this is the constant of, this is the sign of proportionality, which shows that it depends on the length, the tension, and then the mass per unit length. But then we don't know how it's related. We don't know how they relate to this. So what we are going to do is that we are going to say that F depends on L. We don't know whether the sign here is plus, is minus, is to the power, is square root. We don't know. So we are going to place a constant there. We don't know, to show those factors. Okay. So T, Y, mu, Z, where these variables x, y, z are constants we are going to determine. Okay, if you study operation of proportion, realize that you can remove this proportionality sign and bring an equal to sign and bring a constant of proportionality. So here I'm using k as my constant of proportionality. Okay, so k, introducing the constant of proportionality k, because the equation, the proportional equation becomes a normal equation like this: T, Y, mu, and Z. Now we'll be given k as half, so I can just put that into the equation. F is equal to half L x T Y mu Z. Okay, so now our point now is to find x, y, z. Okay, and dimension analysis can help us do that. What we are going to do is that we're just simply going to substitute the dimensions of the left hand side and then the dimension of the right hand side of the equation. So substituting their dimensions, I'm going to substitute for f, it is t exponent -1 being equal to half. For L, it's still L. Now it's no more dimensions, so now my power goes like this. There's no more square bracket but normal bracket. For tension, it is M L T minus 2y. For mu, it is M L minus 1 to the power z. This is z and not 2. Z. C. Okay, so I want to simplify this and open the brackets. If I do that, where do I write? Okay, let me clean this space. Pardon me, my board is not so big. Okay, so I'm going to clean this space. Okay, I'm sorry about that. My team and I are working on getting a bigger board. So for now, yes, pardon us. So this becomes t minus 1 equals half L to the power x, m to the power y, L to the power y, t to the power -2y, multiplying, this is multiplication, okay, multiplying m to the power z, L to the power minus z. See, when I open a bracket, this multiplies this multiplies. Whatever is outside the bracket, multiply the exponent of the terms inside the bracket. So this is what I get. And then this is multiply, whole of this is multiplying this. Okay. So if I continue and I simplify, this is what I'm going to get. I'm going to get half. No, these are like terms. So the exponents will add because they are multiplying. The bases are multiplying. So L. The like bases are multiplying. So from basic exponents and bases, indices, this is going to be Lx plus y minus z. M becomes y plus z. And I have t minus 2y. So what I'm going to do to find my x, y, and z is that I'm going to compare. Remember that if this equation is correct, okay, then the left hand side, the dimension of the left hand side must be equal to the dimension of the right hand side. And now we've written the equation in terms of dimension. So if that is the case, then if you take the individual dimensions at the left hand side, at the right hand side, their exponent should be equal to those at the right hand side. So you might say that, okay, if I take length, I don't have a length at the right hand side. Okay, if you think of them in terms of their dimensions, there is length here, but it cannot be seen. There's a length here, but the power is 0. Remember, any number raised to the power is 0, or any number or variable raised to the power 0 is 1. So if it's not here, then this is 1. And so another way of saying it is that it is L raised to the power 0. Likewise, M is also here, by raised to the power 0. So using that analogy, we can try to equate their indices. Okay, that's what we are going to do to help us find our variables or constant x, y, z. So for L, I'm going to say that the exponent of L, x plus y minus z, is equal to 0. L to the power 0. I'm replacing their exponent. So this will be my first equation. Since there are 3 variables, I will need at least two more other equations to be able to solve this. So if I take m, it's going to be y plus z equals 0 to. And if I take t, equation 2, if I take t, I have -2y equals 1, -1. So that means that my y equals half. This is my equation 3. So I'm going to substitute equation 3 to equation 2 to get c. So my equation 2 becomes y is now half, plus z equals 0. So now my z is negative, this is z, not 2, z negative half. So now I know z, negative half, I know y, half. Now I can find my x by substituting both z and y into equation 1. When I do that, I'm going to get x plus half minus half. minus half equals 0. So this becomes x plus half equals 0. So I'm going to get x plus 1 equals 0. So my x is negative 1. So right now, I've been able to find all my constants x, y, z. So I know that x is half. Sorry, x is negative 1, y x half, and my z is negative half. So I can come back to my equation here and write that the frequency, substitute the values of x, y, z, and even k. I know k to be half, so I can write this equation as f being equal to half L to the power x. My x is 1, so 1. I can choose not to write it. Then t raised to the power y is positive half, so half. And then what's my mu? My mu is to the power z, and z is negative half, so mu to the power negative half. If I rearrange this carefully, this is what I'll get. I'm going to get half L square root of t over mu. You see, if I do it carefully, I realize that okay, I'm not about to go into the details of the mathematics, but then that's how it's supposed to be for the sake of the length of this video. Okay, if you have any question or any qualms, you can text me, as you can email me on my email. Okay, learningwith360@gmail.com. Okay, so because I was able to find the constant x, y, z, I've been able to correctly define the relationship between the frequency of the vibratory string and then the length, if length, tension, and mu. This is how they relate. And so dimensional analysis have been able to take me from here, just knowing that there is a relationship exists between them, to actually finding how the relationship is. So that makes dimensional analysis a very, very powerful. And the mathematics is quite simple. We didn't go through hell, to do this. It was quite simple. And so the only thing you need is the mathematics behind it. Okay, this is not a math course, so I don't want to delve into the details of that. But this is how you solve a question like this. Okay, and then once again, pardon me for the way my body is looking. My body is quite small, but I've done my best to write out the most salient points or the most important things. Okay, so we are going to take another question that is similar to this one, and then we are going to try to solve another question. Don't forget to like, share, and leave your comment down below.